Electric ranges and cooking appliances rated over 1.75 kW shall be permitted to be calculated in accordance with Table 220.55 of the National Electrical Code. The table does not apply to ranges and cooking appliances rated at 1.75 kW or less. Therefore, for ranges and cooking appliances rated at 1 kW, you would use the nameplate rating to calculate the load. This means that if you have an electric range with a nameplate rating of 1 kW, you would use that 1 kW value directly in your calculations, without applying any demand factors from Table 220.55. The National Electrical Code provides specific guidelines for calculating electrical loads to ensure safety and prevent overloading of electrical systems. These guidelines are essential for electricians, engineers, and anyone involved in electrical installations. Section 220.55 specifically addresses the calculation of loads for electric ranges, wall-mounted ovens, counter-mounted cooking units, and other cooking appliances in dwelling units. The key is to understand the appliance's power rating and whether it falls within the scope of Table 220.55. For appliances rated over 1.75 kW, Table 220.55 allows for the application of demand factors, which reduce the calculated load based on the assumption that not all cooking elements will be used simultaneously at their maximum power. However, for appliances rated at 1.75 kW or less, the nameplate rating is used directly without applying these demand factors. This distinction is crucial for accurately sizing circuit breakers, conductors, and other electrical components. To further illustrate, let's consider a few examples. Firstly, if you have an electric range with a nameplate rating of 6 kW, you would refer to Table 220.55 to determine the appropriate demand factor based on the number of ranges connected to the service. For example, if it is a single range, you might find a demand factor that reduces the calculated load to something less than 6 kW. Secondly, if you have a smaller cooking appliance, such as a countertop burner, rated at 1.2 kW, you would use the full 1.2 kW in your calculations because it falls below the 1.75 kW threshold. This ensures that the circuit is adequately sized to handle the maximum potential load of the appliance. The importance of adhering to these code requirements cannot be overstated. Overloading electrical circuits can lead to overheating, which can damage wiring and insulation, increasing the risk of electrical fires. Proper load calculations help to prevent these hazards and ensure the safe and reliable operation of electrical systems. In addition to the specific requirements of 220.55, other sections of the National Electrical Code may also be relevant to range and cooking appliance installations. These might include sections on conductor sizing, overcurrent protection, and grounding. It is essential to consult the latest edition of the National Electrical Code and any applicable local amendments to ensure compliance with all relevant requirements. Now, let's delve deeper into the practical application of 220.55. The table is structured to provide demand factors based on the number of appliances and their ratings. It's essential to correctly interpret the table to determine the appropriate demand factor for your specific situation. The table's headings and notes provide important guidance on its proper use. Firstly, understand the columns, which represent different ranges of appliance ratings. Secondly, identify the rows, which correspond to the number of appliances being served. Thirdly, locate the intersection of the appropriate column and row to find the applicable demand factor. For example, let's say you are calculating the load for 3 electric ranges, each rated at 8 kW. You would look at the row corresponding to 3 appliances and the column corresponding to the 8 kW rating. The table will provide a demand factor that you can apply to the total connected load of 24 kW to determine the calculated load. Keep in mind that the demand factors in Table 220.55 are based on statistical averages and are intended to represent the typical load profile of cooking appliances in dwelling units. In some cases, the actual load may be higher or lower than the calculated load based on the table. For example, if a dwelling unit has a large family that frequently cooks large meals, the actual load may be higher than the calculated load. Conversely, if a dwelling unit is occupied by a single person who rarely cooks, the actual load may be lower. Despite these potential variations, using Table 220.55 provides a standardized and generally reliable method for calculating range and cooking appliance loads. It is also important to be aware of any exceptions or special rules that may apply in specific circumstances. For example, the National Electrical Code may have specific requirements for calculating the load for ranges in multifamily dwellings or for ranges with unusually high power ratings. These exceptions are typically detailed in the code itself or in related publications. Always refer to the latest edition of the National Electrical Code and consult with a qualified electrical inspector or engineer if you have any questions or concerns. In addition to the demand factors provided in Table 220.55, the National Electrical Code also allows for the use of alternative calculation methods in certain situations. These alternative methods may be based on engineering studies or load monitoring data. However, the use of alternative methods typically requires approval from the local electrical inspector or authority having jurisdiction. If you are considering using an alternative calculation method, it is essential to consult with the authority having jurisdiction to ensure that your proposed method is acceptable. They may have specific requirements for the data and calculations that must be submitted to support your alternative method. Furthermore, proper documentation is crucial for all electrical load calculations. Maintain detailed records of the appliances being served, their nameplate ratings, the applicable demand factors, and the resulting calculated loads. This documentation will be helpful for future reference and for demonstrating compliance with the National Electrical Code to electrical inspectors or other interested parties. When documenting your calculations, be sure to clearly identify the code sections that you have relied upon. This will help to ensure that your calculations are transparent and easy to understand. It is also a good practice to include a diagram or schematic of the electrical system, showing the location of the ranges and cooking appliances and the circuits that serve them. Remember, the goal of electrical load calculations is to ensure the safety and reliability of the electrical system. By following the requirements of the National Electrical Code and by carefully documenting your calculations, you can help to prevent electrical hazards and ensure that the electrical system is adequately sized to meet the needs of the occupants. So, to reiterate, if an appliance is rated 1.75 kW or less, you simply use its nameplate rating in your calculations. This is a straightforward approach that ensures that the circuit is adequately sized to handle the appliance's maximum potential load. For appliances rated over 1.75 kW, Table 220.55 provides demand factors that allow you to reduce the calculated load based on the assumption that not all elements will be used simultaneously at their maximum power. Understanding this distinction is critical for accurate and safe electrical installations. It's also worth noting that the 1.75 kW threshold is a specific value established by the National Electrical Code. While it may seem arbitrary, it represents a balance between providing adequate capacity for smaller appliances and allowing for demand factors to be applied to larger appliances. The code-making process involves extensive research and analysis to determine these types of thresholds and demand factors, taking into account factors such as typical usage patterns, appliance characteristics, and safety considerations. The National Electrical Code is a constantly evolving document, with updates and revisions being made on a regular basis to reflect changes in technology, industry practices, and safety standards. It is important to stay up to date with the latest edition of the National Electrical Code and to be aware of any local amendments or interpretations that may apply in your jurisdiction. Continuing education and professional development are essential for electricians and other electrical professionals to ensure that they have the knowledge and skills necessary to comply with the latest code requirements. This commitment to ongoing learning helps to maintain the highest standards of safety and quality in electrical installations. In conclusion, accurately calculating electrical loads for ranges and cooking appliances is a critical aspect of electrical design and installation. By understanding the requirements of 220.55 and Table 220.55, and by following best practices for documentation and communication, you can help to ensure the safety and reliability of electrical systems and prevent potentially dangerous overloading situations. Always consult the latest edition of the National Electrical Code and seek guidance from qualified professionals when needed. And remember, the 1.75 kW threshold is the key to determining whether you use the nameplate rating directly or apply demand factors from Table 220.55. This simple rule, when applied correctly, will help you to comply with the code and create safe and functional electrical installations. Furthermore, always consider the specific characteristics of the installation when performing load calculations. Factors such as the number of appliances, their power ratings, and the anticipated usage patterns can all influence the actual load in the electrical system. By taking these factors into account, you can make informed decisions about circuit sizing, overcurrent protection, and other critical aspects of the electrical design. It is also important to communicate effectively with the homeowner or building owner about the electrical load requirements of their appliances. This will help them to understand the importance of not overloading the electrical system and to avoid using multiple high-power appliances simultaneously in the same circuit. Clear communication and education can play a vital role in preventing electrical hazards and ensuring the long-term safety and reliability of the electrical system. As technology continues to evolve, new types of cooking appliances and electrical loads are constantly being introduced. It is essential to stay informed about these changes and to understand how they may affect electrical load calculations. For example, the increasing popularity of induction cooktops and high-efficiency ovens may require adjustments to the traditional demand factors used for range and cooking appliance loads. The National Electrical Code is continually updated to address these types of changes and to provide guidance on how to calculate loads for new and emerging technologies. By staying up to date with the latest code requirements and industry best practices, you can ensure that your electrical installations are safe, efficient, and compliant with all applicable standards. And finally, remember that electrical safety is paramount. Always follow safe work practices when performing electrical installations and repairs, and never attempt to work on electrical systems unless you are properly trained and qualified. Electricity can be dangerous, and even a small mistake can have serious consequences. By prioritizing safety and adhering to established standards, you can protect yourself, your colleagues, and the public from electrical hazards. In summary, when calculating the load for electric ranges and cooking appliances, remember the following key points. Firstly, 220.55 and Table 220.55 apply to appliances rated over 1.75 kW. Secondly, for appliances rated 1.75 kW or less, use the nameplate rating directly. Thirdly, understand how to correctly interpret and apply the demand factors in Table 220.55. Fourthly, consider any exceptions or special rules that may apply in specific circumstances. Fifthly, maintain detailed documentation of your calculations. Sixthly, communicate effectively with homeowners or building owners about electrical load requirements. Seventhly, stay up to date with the latest edition of the National Electrical Code and industry best practices. Eighthly, prioritize electrical safety in all aspects of your work. By following these guidelines, you can ensure that your electrical installations are safe, compliant, and reliable for years to come. Understanding the nuances of the National Electrical Code, especially sections like 220.55, requires careful attention to detail and a commitment to continuous learning. The code is not always straightforward, and interpretations can vary depending on the specific context of the installation. Therefore, it is essential to seek guidance from experienced professionals and to consult with the authority having jurisdiction when in doubt. The goal is to ensure that all electrical installations are performed in a safe and compliant manner, protecting lives and property from the hazards of electricity. Moreover, remember that the National Electrical Code is not a static document. It is constantly being revised and updated to reflect advancements in technology, changes in industry practices, and new safety concerns. Staying informed about these changes is crucial for all electrical professionals. This can be achieved through continuing education courses, professional development seminars, and active participation in industry organizations. By investing in ongoing learning, you can stay at the forefront of your profession and ensure that you are always providing the highest level of service to your clients. Furthermore, consider the impact of energy efficiency on electrical load calculations. As energy-efficient appliances and lighting systems become more prevalent, the overall electrical load of buildings may decrease. However, it is still essential to perform accurate load calculations to ensure that the electrical system is adequately sized to meet the demands of the occupants. In some cases, energy-efficient appliances may have higher inrush currents or other characteristics that can affect the load on the electrical system. Therefore, it is important to carefully consider the specific characteristics of each appliance when performing load calculations. In addition to the technical aspects of electrical load calculations, it is also important to develop strong communication and interpersonal skills. As an electrical professional, you will often be working with homeowners, building owners, contractors, and other stakeholders who may not have a deep understanding of electrical systems. Therefore, it is essential to be able to communicate complex technical information in a clear and concise manner, and to build trust and rapport with your clients. Effective communication can help to prevent misunderstandings, resolve conflicts, and ensure that everyone is on the same page regarding the electrical installation. It is also important to be a good listener and to take the time to understand the needs and concerns of your clients. By building strong relationships with your clients, you can create a positive and collaborative working environment that leads to successful electrical installations. Finally, remember that the electrical profession is a rewarding and challenging career path. It requires a combination of technical expertise, problem-solving skills, and a commitment to safety and quality. By dedicating yourself to excellence and by continuously striving to improve your knowledge and skills, you can make a positive impact on the lives of others and contribute to the safety and well-being of your community. So, embrace the challenges, learn from your mistakes, and never stop seeking new knowledge and experiences. The electrical profession is constantly evolving, and there is always something new to learn. By staying curious and by remaining committed to your craft, you can achieve great success and make a lasting contribution to the world.